Assalamualaikum warahmatullahi wabarakatuh, and very good day to everyone. So I will continue to discuss the example 4.6. As we look in the slides, a four-wheel car has a mass 2000 kg and a wheelbase 2.5 meter, track width 1.5 meter, and height of center of gravity 500 millimeter above the ground. Lies at 1 meter from the front axle. So this one is the mass, 2000 is the mass of vehicle, and this one is the spec of the car, the specification. Okay, 2.5 meter, lies at 1 meter from the front axle. Each wheel has an effective diameter of 0.8 diameter and moment of inertia 0.8 kg squared. Okay, so this one is for the wheels. So this one is wheel. Each wheel. So there are 4 wheels on the car. The drive shaft, engine, flywheel, and transmission are rotating at 4 times the speed of road wheel. So this one is, the ratio is 4 to the ratio of 1. In a clockwise direction when viewed from the front. So when viewed from the front is clockwise direction. So from the back is anti-clockwise direction. Okay. Clockwise direction when we verify, and is equivalent to a mass of 75 kg, having a radius of gyration 100 mm. If the car is taking a right turn of 60 meter radius at 60 km per hour, find the total reaction force at each wheel. So each wheel and the road surface. Okay, so 75 kilogram the radiation. Okay, so this one is for the precession. Okay, the one is for the precession. So if the car is taking a right turn, so from the figure, the car is going to the front and then making a right turn. Okay, so we need to know, we need to use our right hand rule. From the figure also, we can show that I just draw a simple. Okay, so if the car is moving, if the direction is the rotating of drive shaft, engine, flywheel, transmission, so we will look one by one, because we have we want to find the reaction force at each wheel. So there are forces that act on the wheel, which is from the weight of the vehicle itself, and then the force from the action of the gyroscopes, and also the we have our rotating parts, okay, of the engine. Okay, so first we need to know, and we need to draw our free body diagram of our car. Okay, so we have a car with 4 wheels. Okay, so we can draw this is top view, and the other one we have is front view. Okay, front view. So we know that the car is weight 2000 kilogram, and then we have the explanation that from the slides, they have a wheelbase of 2.5 meter. So the wheelbase is from front to the back. This is 2.5 meter. And then we have track width 1.5 meter. So we have the track width 1.5 meter. The height of center of gravity. So this is top view. This is front view. Okay. 500 mm above the ground level. So let's say that this one is center of gravity. Okay, so this is 500 mm from the ground and lies at 1 meter from the front axle. 1 meter from the front axle. Okay, so this is we are front. Okay, so we are looking from the front and top view. So the center of gravity lies 1 meter from the front axle. So let's say this is our center of gravity. So the center of gravity lies 1 meter from the front axle. Okay, first we need to find our we need to know and we need to calculate the force that act on our wheels. Okay, so we need to draw the free body diagram of the vehicles. Okay, so from the front, this is front, this is rear, front and rear, and the center of gravity is 1 meter from the front and 1.5 meter from the rear wheels. Okay, so we know that the weight of the vehicle is 2000 kilogram times 9.81 the gravity. Okay, and then we got our weight is 19,620 meters. So we need to calculate the force on the front and rear wheel. So we can calculate the moment that act on F point. So moment at the front wheels is equals to W times 1 meter. Okay, so we take this one as positive. The weight times 1 meter, and this is the positive and that one is negative. R times 2.5 meter. Okay, and for the equilibrium, the moment is becomes 0. So we can from the equation we can find that R is equals to W times 1 over 2.5 equals to 19620 over 2.5, and the R is equals to 7848 Newton. And then we can calculate the F is equals to F equals to 19,620 minus 7848. So the force act on the front wheel is 11,772 Newton. Okay, so the total should be 19,620 Newton. Okay, so this is for the front and rear, but for each wheel, okay, for each wheel, we have two front wheels and two rear wheels. Okay, so we just divide the answer by 2. So each of our front wheels, F1, F2, front wheels will 772 divided by 2 is equals to 5886 Newton, and rear left and right is 57874 divide by 2. Is it 7874? Sorry. No, that is 77848 divided by 2 is equals to 3924 Newton. Okay, so this is for each wheel. Okay, and then since the weight of the car over the four wheels will act downwards, okay, the weight of the car is downwards, so the reaction force for the reaction force on the weight of the car will react upwards to the wheels. So that's mean if we have our wheel, this will act, this is rear, this is front. So rear is 3924 Newton and front is 5886. Bear in mind that the figure should be like this. This is front, this is rear. So this is the force, reaction force on the wheels. But we just draw it like this one. But bear in mind that the reaction force on the wheels is like the 3D one. Okay, that's for the force coming from the weight of the vehicle. Okay, now let us have a look at this one is from the weight, and let us have a look for the gyroscopic couple made from the wheel. Okay, let's say I draw this. Okay. This is front and this is the rear. So for the wheels to move forward, okay, for the wheels to move forward, the wheels will go like this. Okay, so to move forward, the wheels will, the angular velocity is on this one. So this is our pointing finger. And then from the question, it says that the car is taking a right turn. So from the car moving to the front and taking a right turn. So taking a right turn make the precession angular velocity going down, the vector, okay, going down. So from the right hand rule, this one is our angular velocity from wheels, okay, and then the precession of our right turn of the vehicles. So this one is for the precession. So we have our right hand rule, one this way, and then the active couple. Okay, so this one, the active couple, active, and this one, the reactive couple. So the reactive couple will act like this. That one. Okay. What does it mean? The reactive couple tend to move. This one is when we do a right turn. This one is the inner. This one is outer. So when the vehicle's turning to the right, we have our reactive gyroscopic couple react on the wheels. So we got this one. This is the reactive couple, and that will make on front wheels. Okay, so we look at this one. So the action of the couple will press the outer wheel, will press it down. Okay, and then will lift up the inner wheels. Same goes to the at the back. So the reactive couple will so the reactive couple will try to put the outer wheels, try to press the outer wheel and lift up the inner wheels. That's the reaction of the reactive couple. But what happened to the wheels? Wheels will react. The wheels will react to the. The wheels will react to the gyroscopic couple, and the wheels will react the opposite direction. Okay, this one will react the opposite direction. So that is the reaction of the wheels, the reaction of the wheels because of the reactive gyroscopic couple. Okay, so we need to calculate the rate force that acting on the wheels. So we have our okay, so we have our movement. We need to calculate our angular velocity. So for the wheels, we can calculate for the wheels is equals to, we need to change the velocity from 60 kilometer per hour of the vehicles to meter per second. So 60 kilometer per hour times 60 minutes, sorry, times 1 hour over 60 minutes times 1 minute over 60 seconds times 1000 meter over 1 kilometer. So we get the answer of 60 times 1000 over 3600 meter per second. And we get the answer is 16.67 meter per second. Okay, now we have our velocity, and then we can calculate our angular velocity, depends on our radius. So the velocity is v over our wheels, and we got 16.67 is divided by our 0.8 diameter, which is the radius is 0.4, and we get 41.675 radian per second. Okay, that is the angular velocity for the wheels. And then we can calculate our precession. Okay, so the precession is 60 kilometer per hour turning to the right with a 60 meter radius, and we got 16.67 meter per second over 60 meter radius, and then we got the answer 0.278 radian per second. Okay, so the gyroscopic couple, we have, okay, so we calculate our gyroscopic couple, m is equals to I omega p. Okay, so we have I equals to 0.8, angular velocity is equals to 41.675, and we have 0.278. Okay, okay, from and then we calculate, we got 9.2685 Newton meter. Then we have 4 wheels, so the totals of the gyroscopic couple for the 4 wheels is equals to 4 times 9.2685 equals to 37.07. Okay, that is the relative gyroscopic couple for the 4 wheels. Okay, we know that the gyroscopic couple will lift up the inner, this is the gyroscopic couple, lift up the inner wheels and press the outer wheels. Okay, so the reaction of the tire will be opposite. Okay, okay, then we got our which is 3707. So 3707 Newton meter. And we have our wheels. Okay, so basically this moment acting on the front and rear, so we need to divide it by 2, so we have 18.5535 for the front and rear wheels. So we just calculate the front wheels. So from the moment, it act this way. Okay, so the moment will act that way, and we have our base is 1.5 meter. Okay, so the moment, the total moment for the equilibrium is as I said before, that the the gyroscopic couple will act this way. Okay, and the reaction of the tire will act the other way. So the other way is this way. Okay, the reaction of the gyroscopic couple. Okay, so this is for the front, and then we can calculate the moment 18.535 divided by 1.5. Okay, or else you can calculate the equation of moment that way is positive. So we have our moment 18.535 is equals to front 1 and then this front 2, front 1 times 0.75 meter plus front 2 times 0.75 meter. Okay, so we can get our F1, F2 is the same, equals to 12.36. Okay, so this will act on our front and rear. Okay, so this one will this is this one is Newton meter and this one is meter, so we cancel the meter, so this one should be meter. Okay, 12.36 meter. Alright, so from our figure, so the act of the vehicles, the tire, okay, we got our force is 12.36 Newton, okay, and the force, this one, okay, F1 and F2, inner is going down, outer is going up. Inner is going down for both, outer is going up. Okay, so we have our inner, this one, inner, and this one is outer. The one is 12.36. Okay, that one is from the wheels, and we have also our gyroscopic couple from the engine. Okay, this is from the front view. We have our in a question. It says that the drive shaft, engine, flywheel, transmission rotating at 4 times the speed in a clockwise direction when viewed from the front. So it is a clockwise direction from front. Okay, so we can draw it here. Clockwise direction from the front. So this is front. Okay, from 3D figure, that one is front. Okay, so the engine rotates this way from the front, clockwise from the front. So the vector of angular velocity is x to the back. So from our thumb rule, it is to the back. So that one is our pointing finger. And then from the question also, it says that the vehicles, the car turning to the right. So front and turning to the right. Turn right. When it turn right, so turn right, our thumb rules, the vector is going down. So turning right. So this is our pointing finger. Pointing finger. This is our thumb. Okay, pointing finger, thumb, and that one, okay, is our middle finger. Middle finger is active gyroscopic couple. So the reaction of the reactive couple is to the right of the car, the right hand side of the car. But in the figure is on the left. Okay, so from the figure we can say that this one, using our thumb rule, okay, it shows that the reactive couple, gyroscopic couple moment is acting like that. And what is that mean? Okay, so we have our front here. From the figure, okay, the action of the reactive couple, reactive gyroscopic couple is this way. Okay, so that means the gyroscopic couple will turn the rear tire, will press the rear tire, press the rear wheels and lift up the front wheel. Okay, so the gyroscopic couple will act like this. Okay, so it will results in the rear wheels going pressed and front wheels going lifted. Okay, Okay, so we need to calculate the moment. So from the figure we have our moment of inertia. So we have uh, I equals to mk squared. This is for engine, shaft, and all. That it says that the total of mass is 75 kilogram, and the gyration is 100 mm, which is 0.1 meter. And then we got the answer of 0.75 kg squared. That is for our I. Okay, we need to calculate for our gyroscopic moment. So so M for engine and all is equals to I omega E omega P. Okay, so we have our omega E and omega P. Omega E is 4 times of the wheels. We have the ratio here from the question. The transmission rotates 4 times of the wheel. So we can calculate our omega E 4 times 41. 4 times 41.675. 41.675 radian per second. 4 times 40.675 equals to 166.7 radian per second. Okay, and then we can calculate our moment is equals to 0.75. This one is second moment of inertia. We have our omega E times 166.7 and we have our precession. Precession is this one, 0.278 times 0.278 radian per second. So we got our answer 34.7. Just to make sure it is correct. 34.776. Okay. This the gyroscopics, as I said, the gyroscopic this one. So I will color this one in okay. As I said, the gyroscopic couple will tend the rear wheels, will press the rear wheels and will lift the front wheels. So the reaction force of our wheels is this one. Okay, so we need to calculate the moment of the force that react on the wheels. And we have our front wheels. front, rear. This is 1 meter and this is 1.5 meter. And the moment that at the center of gravity, this is the moment that at the center of gravity is 34.7. Okay, and then we need to calculate the force, the reaction force that this is for the front and this is for the rear. Okay. Okay, so we can calculate for the engine. So we have front and rear. Okay, so we can two wheels at the front and two wheels at the rear. Okay, so first we can divide it 34.7 divide by 2, and we can times 2.5. This is the base. Okay, 2.5. So we got the answer of 6.94. Okay, so 6.94 Newton acting on each wheels, but the wheels at the front is pulling down, at the rear is lifting up. Okay, the reaction. So front, front is going down. So front is 6.94, front 6.94, back up 6.94, up 6.94. Okay, then we need to consider the centrifugal force, and we need to calculate the centrifugal force. Okay, and finally we need to consider our centrifugal force. So for the centrifugal force, imagine that we have our vehicles. Okay, this is our vehicles going to the front 60 km per hour, and then making a right turn. So the car will make a right turn. That one is front for easy understanding. So 60 km and making a right turn. What do you feel? Making a right turn, what do you feel? You will feel that the pressure on the inner wheel, so this is inner, this is outer, from the inner wheels will reduce. The car will try to rotate and lift up the inner wheels, while the outer wheel will be going down. So this is the centrifugal force of the 60 meter radius of right turn. Okay, so to calculate the centrifugal force, the force of centrifugal is equals to mass of the car times the velocity, and divide by r radius of 60 meter. So we can calculate 2000 times 16.67 meter per second square, and then 60 meter, and we have our force is 92.63 Newton. Okay, So this is the centrifugal force that act on the center of gravity. So we have our center of gravity 500 mm, which is 0.5 meter. Okay, so that our FC for the centrifugal force, okay, moment of the centrifugal force is 9263 times 0.5 meter is equals to 4631.5 meter. Okay. Okay, so that one is for the moment of the centrifugal force, but we need to divide it by 2 front and so 4631.5 divide by 2, and the moment is 1.5 meter because of the base is 1.5 meter. So we get the 1543.83 Newton acting on the wheels. So each wheels. Okay, the moment will the reaction of the centrifugal force will this one is for the action, and the reaction, okay, the reaction of the inner wheels will be downward and the outer wheel will be upward. That is the reaction. So if we have our car, okay, this is different from the above figure because this is referring to the previous this one. Okay, so turning right, this is the front and making a right turn. Okay, all right. So the centrifugal force will act the inner and outer. So the inner will be downwards and the outer will be upwards. Okay. Okay, so the value is the same, 1543.83 Newton. So we have our how to copy. Wait, I try to okay, got it. Okay, so we have our front wheel 1543.83. So this one is going down, this one is up, this one is down, and this one is up. So the magnitude is 1543.83. 1543.83. So we have our front wheel number 2, rear wheel 1, and rear wheel 2. Okay, then we need to calculate the um, force for each wheel. Okay. Okay, so we get for the front wheels looked front wheel F1 is equals to 5886. Okay, so this one 5886 minus 12.36 minus 6.94 minus 1543.83. That one is equals to 4322.87, also at 5. Okay, and then we have our front wheel number 2. We have 5886 minus plus 12.36 minus 6.94 plus 1543.83. Okay, the answer is 7435.25. We have our rear wheels. Okay, so rear wheels equals to 3924 minus 12.3 minus 12.36 plus 6.94 minus 1543.83. Okay, so the real wheels is 2374.73. Last one is R2 equals to 3924 plus 12.36 plus 6.94 plus 1543.83 is equals to 5487.1. Okay, that is the load. I just need to. Okay, so that's a correction. This one is 7 Newton, and this one is 2374.75 Newton. That's all for example 4.6. Okay, I left to you example 4.7 because there's a solution given. Example 4.7, example 4.8 with the solution, example 4.9, and also example 4.10. there's a solution there, so you can go through. Okay, then we have got this book. Okay, we have another example on gyroscope, which is the example 4.11 and exercise 4.11 and exercise 4.12. I want you to do that. Okay, I want you to do that so that you to make sure that you understand the chapter on gyroscope. Okay, so thank you guys. We'll see in the next subtopic, next chapter of shaft and bearings. Thank you. Thank you so much. Bye.